Hello everybody, welcome to the World of Control channel. I'm Mohammed, and in this first video, I want to talk about designing a neural network and training it with some real data that can identify a simple model like our inverted pendulum. In the previous videos, I talked about some different controllers and also modeling the inverted pendulum. Also, this system is very simple and easy to write the dynamic of that. But if we understand how to design a neural network model and train it with our data to identify the dynamics of our system, we can also design different neural network models for other complicated models. Uh, in this first video, I want to show you how to store the data from our Simulink model that we can use it for designing and training our neural network model. In the second video, I want to write the main code that trains the neural network model and also show you how to use the different commands in MATLAB that can actually train the neural network. And in the last video, I want to actually evaluate and test our neural network and actually show our results and the performance of our neural network. As you can see in this file here, we derived the dynamics of the inverted pendulum, as you can see in the previous videos. But what if we didn't have the dynamics of our system? In this case, the dynamics of this system is very simple and easy, and we can derive it with a simple equation. But if we had a complicated model that has a very difficult dynamics with multiple inputs and multiple outputs, we actually couldn't write the dynamics of the system very easily. So in this simple video, I want to show you how to store the data from our model and see what we can do next with the neural network. So I will go to our model that we developed it in the previous videos. This is the dynamics of our inverted pendulum. These mass value and the length of our pendulum, actually these values are arbitrary, so we can modify it with respect to our actual system. Okay, the first step to design a neural network model to identify a dynamics is data storage. We need to have some data. So how can we store our data in Simulink? This is our model. First, I want to run it for first time so we can see the actual theta that is degrees in the units of degree and our theta dot, as you can see in this figure. And also in this case, our input, that is the torque that is applying to the pendulum is given a random number. A random number, if we click on this block, we can see that we can justify and modify the mean and the variance of our random number. We want to use a actually white noise input, so we will input 0 for the mean and the variance, for example, 1. And in this block there's something very important that is our sample time. Actually, how many data do we need to store, or do we want to store? This actually, this value here that I input in sample time says that each 0.001 seconds the Simulink will actually, this block will apply and a different random number input as our torque to the inverted pendulum. So it is very important that we use a appropriate sample time for our model and our dynamics. Okay. To store the data, we need the input and the output of the system. Okay, I will click on the Simulink model here and I will write to workspace and I will enter a to workspace block here. Okay, I will click on it, and in this block we have a variable name. We need to set a variable name for our data that we want to store it. So I want to store the input, so I will use U letter for the input data here, and I will choose the format of the storation as structure with time. And the sample time here, as we can see, we need 0.001, and I apply it here and okay, and I will actually connect this block to workspace here to our input signal here. We need to store the output of our system too. So I will create another to workspace block and I will type down the name of our output actually as Y here, and our sample time is actually the same. Apply and OK, click OK, and after that I will connect this block to the theta signal. And now our Simulink model is ready to store our data in the workspace of the MATLAB. So stop time is 10 seconds is good for now, and I will run the simulation. Okay. As we can see now in the workspace, we have a variable named out. If I write it in the command window and enter it, we can see that it has 3 variables in it. Actually, it is a string. It is a structure that has 3 variables in it. So we can write and actually write each variable in the variable that we need here. Okay, we can say out dot t out here, and the dot here will access the will access to the t out here, and we will store it in the time variable here. If I click actually if I enter this, we can see that there it is created a variable time here that stores the time of each time step that the simulation was run. Okay, u is equal to out dot u, and y is equal to out dot y here. As we can see, our data is in the appropriate variable here. If I enter u and enter, I can see that the u is a structure that has a time and a signal in it. So we can store our u in a variable, in a matrix, and we can access to it in the next videos. If I write save double quotation u and u, and if I let me change the directory to where I want to store our data, and if I now enter in the current video, we can see that it created a u matrix here that has our u structure in it. Okay, and I will save the output y as well, and we can see that we have our u and y here now, that we can use it in the next videos. If we want to see that what is in our data here that we stored, if we double click on u.mat, we can see that a command is shown here that says that load u.mat, and we can see that in the workspace we have u now here. Okay, and we can see that u is a structure with time and signals. If we need to access the time, we can simply say u.time, and we can see that all the time samples are shown here. And if we need the values, if we type u.signals, we can see that it is a structure that has values in it. So if we say u.signals.values, we can see that the input values and now is here, and we can use them to train our neural network model. In the next video, I want to use this input and output data to train my neural network model and actually use it to identify our inverted pendulum dynamics. Thank you very much. Make sure that you subscribe this channel. I will create a lot of videos in this field, model different systems, complicated, simple ones, and I will design different controllers for different models. So make sure that you subscribe my channel. Thank you very much.